Hello everyone. So in our previous video, we saw a basic introduction to selection sort, and we also saw a demonstration that how selection sort is applied on an array having unsorted elements, and once the algorithm is applied, all the elements become sorted. So here let's suppose we are given with this array where the elements are unsorted. So in selection sort what we actually do is we divide the array into two parts. One is the sorted part and other is the unsorted part. So at the start, all the elements are part of unsorted part. And we have this boundary here. So what we actually do, we simply find out the minimum element in the unsorted part. So here let's say the minimum element among all these elements is 1. So what we do is, we pick 1 and we simply swap it with the leftmost element of the unsorted part. And once we swap them, so it would look something like this. And we know that 1 is at its correct position because we want to sort the elements in ascending order. So after the swap is done, the element now becomes part of the sorted array. So the boundary goes here that we have now one element in the sorted part and rest of the elements in unsorted part. So this process is repeated for each and every element on the unsorted part till this boundary reaches to the end of the array. So when all the elements are sorted, the unsorted part has 0 elements and all the elements are in sorted part. So in our previous video we saw step-by-step demonstration of the algorithm. Now we'll see the step-by-step demonstration of the actual code. So here you can see this is the algorithm to perform the selection sort on an array, and this algorithm will sort the elements into ascending order. So let's say when we call sort method and pass in an array. So let's suppose this is our array having 5 elements 5, 1, 10, 2 and 9. Now here you can see they are indexed from 0 to 4. Moving ahead, in the first step what we do is we simply store the length of the array in an integer variable n. So value of n is 5 because we have 5 elements. Moving ahead, also friends, in our previous video we discussed that we divide this array into two parts, the unsorted part and the sorted part. So when we start the algorithm, the sorted part has 0 elements and unsorted part has all the elements. So here basically what we do, we find the minimum element in the unsorted part, and once we find that out, we simply swap it with the leftmost element of the unsorted part. And once the element is swapped, now that element becomes part of the sorted array and this boundary will get shifted by 1 position. So here you can see this outer for loop goes from I equal to 0 to a value I less than n minus 1. So here basically I will keep the track of this boundary, and here you can see it will start from 0 and it will go to less than n minus 1, which is 4. So it will go till 3 here. So why we traverse I to less than n minus 1? Because when we are on the last pass, the last element goes to its correct position and we don't perform this algorithm on the last element because we know that that element is at its correct position. So we will see the demonstration of the algorithm and it will be more clear to you. So currently we'll start with I equal to 0 and 0 is less than 4. So the condition in for loop will be true and the for loop will execute. So here whatever the value I is holding, it will be simply the indexes of this array. So it can be symbolically represented like this. So in selection sort, our first task is to find the minimum element among the unsorted part. So here you can see we first assume that, let's say, whatever the value I is holding, we treat it as the minimum value. So here we create an integer variable and we store the value of I. So min will also become 0, which signifies that we are assuming that value 5 is the minimum element among these all the elements. And now we provide the inner for loop. Now this inner for loop is for actually finding the minimum value. So here this is our assumption, and in order to find the minimum value among all these elements, we need to compare this minimum value with all the elements of this array. And once we find any value which is less than the minimum value, our min will point to that value. So let's see how. So here this for loop will start from I plus 1, because here you can see we are assuming that 5 is our minimum value and I is pointing to it. So we start this inner for loop with j equal to I plus 1. So here you can see value of j will become 1, which is 0 plus 1. So which signifies that we are starting from this value, because we need to compare now 5 with each and every value of this array. So j starts from I plus 1 and it will go till j is less than n. So less than n will becomes 4, because we want to compare it with each and every element. So last index of j would be 4. So let's move ahead and see how it works. So in the first step, we are simply comparing that whatever we assume to be the minimum value, is the value at jth index less than the index value which min is holding. So here you can see the value at array of min would be 5 and array of j would be 1. So now we'll simply compare these two values, and here we are checking that whether 1 is less than 5 or not. So here you can see this condition comes out to be true. So as we have found a minimum value, now what we'll do, we'll simply update the minimum to this value. So whatever the value j is holding, which is 1, now min will point to this value holding a value as 1. So min becomes 1 and symbolically it will point to an index 1. Moving ahead, we'll increment j by 1, because now we need to compare this 1 with rest of the elements. So j becomes 2. Now we'll compare these two values and we check whether 10 is less than 1 or not. So 10 is not less than 1. So this condition comes out to be false. We'll increment j by 1. So j becomes 3. Now we'll compare these two elements. That value of array at min index is 1 and value of array at jth index is 2. So we'll now compare these two values. So here you can see 2 is not less than 1. So this condition comes out to be false. We'll increment j by 1. So j becomes 4. And now we'll simply compare 1 with 9. And we'll simply check here whether 9 is less than 1 or not. So 9 is not less than 1. So therefore this condition comes out to be false. And now we'll increment j by 1. So j will become 5. Which means that j is now out of these boundaries. And this condition here you can see j should be less than n. So j value is 5 and 5 is not less than 5. So therefore this for loop will terminate. And we simply reach here. So here you can see that we have found out the minimum value among these elements, which is 1. And in selection sort, what we do is we simply swap it with the leftmost element of the unsorted part, which is being held by the value I. So here we are performing this swap using this temporary variable. So in the first step, we are storing the value 1 into the temporary variable. So temp becomes 1, and then we are simply swapping the value at ith index, which is 5, into this index. So 5 will come here, and at the last step we are simply assigning value stored at temp into the ith index, which is this. So we have simply swapped these elements, and after we perform this swap, we know that 1 is at its correct position because we need to sort all the elements in ascending order. So now this 1 will go into the sorted part, and rest of the elements will be still in the unsorted part. So the call will reach here in the outer for loop, will increment I by 1, so I will become 1. So now I will point to this index, which is 1. In the first step, we are assuming that let's say this is our minimum value among all the elements. So we are simply assigning value of I to min. Moving ahead. Now as we need to find the minimum element from the unsorted part, we need to provide this inner for loop, which will start from j equals to I plus 1. So I is pointing to index 1, so j will start with index 2. And the value of j, which is 2, is less than 5. So this condition comes out to be true. So now here again we are simply performing this check that whether 10 is less than 5 or not, by taking in the value at jth index and the value at min index. So min is pointing to index 1 and j is pointing to index 2. So we are taking these two values and we are comparing that whether 10 is less than 5 or not. So this condition comes out to be false because 10 is not less than 5. We'll increment j by 1. So j becomes 3. So still you can see 3 is less than 5. So this condition comes out to be true. Now we'll compare these two values. We check whether 2 is less than 5 or not. So yes, 2 is less than 5. So this condition comes out to be true. And as this condition comes out to be true and we need to find the minimum element among these elements, so now our min will point to this index because we have found a minimum value. Moving ahead, we'll increment j by 1, so j becomes 4 and 4 is less than 5, so this condition comes out to be true. Now here we check that whether 9 is less than 2 or not, so 9 is not less than 2, so this condition comes out to be false. J becomes 5. So now this condition 5 is not less than 5, so this for loop will terminate. And we have found our minimum element, which is 2. So we'll simply swap it with the leftmost element of the unsorted part, which is being tracked by the value I. So we are simply swapping 5 with 2 using these 3 steps. So we'll quickly go over these 3 steps. Temp will have value 2 with this statement. We will transfer 5 to this position by assigning the array value at ith index to the array value at min index. So this becomes 5. And at last we'll store the value of temp into the ith index. So this becomes 2. So friends, here you can see after we perform this swap, now 2 will also become part of the sorted part. With each pass, the sorted array is increasing and the unsorted part is decreasing. So now we'll increment I by 1. So I becomes 2. and 2 is less than 4. So this condition comes out to be true. So now we need to find the minimum element among this unsorted part. So we are assuming that whatever the value I is holding currently, it's the minimum value. So we are simply assigning value of I to min. So value of min will become 2. And now we need to compare 10 with rest of the elements. So for that we need to provide this inner for loop where j will start from I plus 1 because we need to compare this with other elements. So I is already pointing to this element, so we'll start j by I plus 1. So j becomes 3. Now we'll simply compare these two values. And here we are finding that whether 5 is less than 10 or not. So this condition comes out to be true. So we have found our minimum element after this comparison. So we'll simply update min to this value 3. And we continue with our for loop. We'll increment j by 1. J becomes 4. And 4 is less than 5. So this condition comes out to be true. Now we simply check whether 9 is less than 5 or not. So 9 is not less than 5. So this condition comes out to be false. We'll increment j by 1. So j becomes 5, which is out of bounds of this array. And here 5 is not less than 5. So this condition comes out to be false and our for loop will terminate. So here you can see we have found our minimum element, which is 5. Now we'll simply swap it with the leftmost element of the unsorted part, which is being tracked by value I. So we are simply performing this swap where 5 will come to this position and 10 will come to this position. So here after we perform swap, now 5 is at its correct position and now this will become part of the sorted array. We'll increment I by 1. So I becomes 3. And 3 is also less than 4. So this condition comes out to be true. Now at the first step we assume that 10 is the minimum value. So we simply assign the value of I to min, which is 3. So it will point to the third index. And now we need to find the minimum element from the unsorted part. So only 2 elements are left. So we'll start our inner for loop with j equal to I plus 1. So j will start with 4. 4 is less than 5. So this condition comes out to be true. And here we'll simply compare that value at jth index, which is 9, is less than value at min index, which is 10 or not. So 9 is less than 10. So this condition comes out to be true. And we have found our minimum element among these two elements. So min will be updated to 4 by assigning the value of j, which is 4, to min. We'll increment j by 1. So j becomes 5, which means that 5 is not less than 5. So this condition comes out to be false. And then as we have found our minimum element, we'll simply perform a swap with the leftmost element of the unsorted part, which is being tracked by I. So 9 will come to this position and 10 will come to this position using this temporary variable. So first 10 will come here, and then whatever the value is stored here, which is 9, will come here. So after this swap, we know that 9 is at its correct position, so this will be part of the sorted array. So friends, here you can see that at the end there were only 2 elements, and as we sorted the second last element, the unsorted part was left with one element. So this algorithm should not be applied to this element because this is already sorted, because this is at its correct position only now. So therefore we provided this condition that I should go to less than n minus 1. So here if we increment now I by 1, I becomes 4. So I will come to this point, but here you can see 4 is not less than 4, which makes sense because now I is pointing to the last element, and if it is the only element left, then we are sure that the last element is actually sorted. So friends, here we saw the demonstration of the selection sort algorithm step by step. And once this algorithm gets finished, we found all the elements sorted into the ascending order. So now let's go to IntelliJ and code this algorithm and test its working. So friends, I hope you have liked this video. And in case you have liked this video, then I would request you to please like, comment, share and subscribe my channel. Thanks, have a nice day.